why I wrote it really big whenever we talked about this last class period is we're subtracting this line from the one above it. Now, in most cases where it's addition, that doesn't make a huge difference. But where you have to be careful is whenever you have subtracting a negative number. What happens when I have two negatives? Turns into a positive. So that means I'm actually going in and I'm adding those two values together so that they combine and become a bigger number. Goal of this is always that first term is going to go away. 4x to the fourth minus 4x to the fourth is 0. Technically, you don't have to write the 0. Now, when I go in and I do x cubed, because this is really 1x cubed, plus, because we just said two negatives make a positive, 1x cubed plus 4x cubed. What's 1 plus 4? 5. So I'm going to have at the bottom 5x cubed. Common mistake that we see, because we don't want you to make it. The exponents themselves, the x cubed and the x cubed, you don't add those two things together. Hopefully we know that, but I'm going to over clarify. It's not going to become x to the 6th. It's just going to say x to the 3rd. Now, what I like to do, just to keep things organized, is everything else that I have, I know in normal division, you only bring down things that you need. I bring everything down. So this is just to keep all of my terms together so that I don't forget that there was something at the top and stop doing division too early. So then, we've gone through one round. Now I have to go in and do it again. So I'm focused on the 5x cubed, and I'm still using x. So again, breaking this down in simplest terms, x times something has to equal to 5x cubed. So what do I have to put in the blank for that to be true? Squared. So I have to put in 5x squared. So I'm going to go in, I'm going to write 5x squared at the top. So now that I have 5x squared, I repeat those same exact steps. I'm going to multiply, I'm going to write it underneath, I'm going to subtract. So I'm going to have 5x cubed minus 5x squared, and I'm going to remember that I'm subtracting from the line above. First term should always cancel, and be careful with your double negatives because that's not going to be minus 5x squared, it's going to be plus 5x squared. So what's negative 1 plus 5? Positive 4. So I'm going to have 4x squared, bring everything down, minus 5x plus 1. Now, you keep going until you can go no more. So I can still work with this. I can still take x and I can still multiply it to be 4x squared. So repeating that process, I am focused only on this 4x squared using my x. I need to figure out x times something is equal to 4x squared. What goes in the blank? 4x or 4x squared? 4x, because I just want to make x squared. So I'm going to go in, I'm going to do plus 4x. Repeat the process. 4x squared minus 4x. Subtract from the line above. And first term should always cancel. And then I'm going to have negative 5 plus 4, which is negative x. Oops, let's keep this in the same color family. Negative x. And then I'm going to bring down my plus 1. What is, because technically we can still go, I'm trying to make, let's see, I'm trying to make negative x. I have positive x. So x times something is equal to negative x. Negative what? 1. Negative 1. Now remember, in these cases, the sign is very, very important. So if we have a negative that you are using to be your multiplier, whenever you write it in the quotient, it has to be negative. If you are changing the signs, that's not going to necessarily be the right answer. So in this case, because I'm running out of room, negative x plus 1. If I subtract from the row above, Both things end up canceling. We end up with 0. Because negative x plus x is 0, and positive 1 minus 1 is 0. So in this case, we end up with no remainder. Any number that you got at the very end would be written at the very end of your quotient, and it would be written over the divisor. Since we don't have one, we can technically come in and say everything that we have up here works as our solution. So this is our quotient. Now, this is what we covered last class period. Nothing in this problem was brand new. This was all from the 4.3 notes. Now we're going to go in and we're going to talk about a method that we can use for shorthand. Now, doing all of these steps can be kind of time consuming, especially when you have a really, really large divisor or large dividend. You can get a problem where you have 4 or 5 terms that you're working with. So what we have to kind of solve the issue of going through this process again and again and again is something called synthetic division. So think kind of like what we did with Gaussian elimination. Gaussian elimination was just another form of solving a system. So instead of doing substitution and elimination where you had the x's and y's in the problem, it took the x's and y's out and you dealt only with the numbers. That is kind of what synthetic division is for polynomials. So one little note here, whenever you want to do synthetic division, it's only ever going to work when you have a divisor that is x plus or minus a number. Go ahead, Gabe. If you have anything else, so if you have 2x plus 1 or 2x minus 3 or x squared plus 2, anything that is not of the form x plus or minus a number, synthetic division will not work. So this is a very special case type of division. You will have to do synthetic division on your test. So there will be a problem that will say solve by long division, and there will be a problem that says solve by synthetic division. So you have to know both methods. Now, if you wanted to go in and check that your synthetic division is correct by doing long division, if you have time, you absolutely can, but we have to see you doing synthetic division. So the way this kind of works, it's very much just like you have to know the steps, and if you know the steps, it's easy, but seeing the steps happen kind of gets confusing. So what's really going on is we're going in and we're kind of doing the division we do for long division almost in reverse. Instead of subtracting things, we're adding things, but we're only dealing with the numbers. So what we're going to do, if you look at number 2, it's the same exact problem as number 1. It's just we're going to do it with synthetic division. There are instructions on the left-hand side. I do think they get a little overcomplicated. I'm going to kind of walk you through this step by step. The first thing that we typically do is we go in and we draw a really big L, almost. Now, what's going to happen is there's a couple of things that you have to kind of place onto the synthetic division. I call it like a box. I want to go in, and on the inside of my box, I'm going to go in and pick all of the coefficients of my dividend. So the dividend part is going to go inside the box. So my first coefficient, a coefficient is the number in front of the variable. So my first coefficient is 4. So I'm going to write the number 4. Remember, we only want numbers for synthetic division. We don't want variables. So 4, a positive is just a 1. A negative is a -1. I have -5. I have +1. So I literally just took the numbers that I have in my dividend and I wrote them out. Now, one little note here. If you are missing a term, what do you think has to go in the place of the missing term? 0. So the same exact way when we were doing long division, we filled in 0x squared or 0x cubed. If you're missing a term, you have to fill in a 0. Otherwise, your whole synthetic division is going to get you the wrong values. The next thing we're going to do is you are going to take the divisor and you're going to set divisor equal to 0. So if I set x minus 1 equal to 0, what is x going to be?
Pardon this interruption. If all of the students who are with Ms. McKinney and avid one who are attending the field trip today, you may be released to head down to the gym area near ROTC to leave the field trip. Thank you.
Okay, so if I set x minus 1 equal to 0, what does x equal? 1. So this number is going to go outside. Stay with me. I know this is going to be weird. So normally, whenever we do long division, and I'm going to kind of reference back to number 1 and back to 2 just to kind of show you how we're getting the same thing. What is the first number in our steps for long division that we tried to make? What was the first coefficient? So of that x to the 4th term, what was the first number? 4, right? The number at the very front of that problem, of that term, is 4. So what happens with synthetic division is the first number that you see, you just drop it down. It just goes down. Because that's the number we're trying to make either way. Now, with all of that, here's where the weird stuff happens. We are going to multiply, and instead of subtracting, we are going to add. Now, it's because of the nature of how the multiplication and all of that works that we do it this way. But really, again, the focus for you is knowing the steps, and we're not going to necessarily make you go out and prove that this is a true equation. So what I'm going to do, kind of following along with what I have 1. I'm going to multiply 1 times 4, and I'm going to write it underneath the next number. So 1 times 4 is what? 4. So I'm going to write number 4 underneath this number. Okay, stick with me, stay with me. I just said we are going to do addition instead of subtraction. So I'm going to come in, I'm going to add these two numbers together. What's 1 plus 4? 5. So I'm going to have 5. Now, the next thing, I'm going to again reference back to the problem we just did. What was, if I look back at number 1, what was the next coefficient that I was trying to make?
4.
I made 4 the first time. What about the second time? 5. What number did I just get from synthetic division? 5. So we are going to repeat this process. I'm going to take this number, I'm going to multiply it by 5, and then I'm going to write it underneath the next number. What is 1 times 5? 5. I'm going to add, what's 5 plus negative 1? 4. Okay, let's look back at what we just did in number 1. The next number that we needed to make was what? 4. What number did I just get from synthetic division? 4. So this process is kind of doing the division for you without the x terms. So let's go again. I'm going to take the number 1, I'm going to multiply it by 4, I'm going to write it underneath the next value. So 1 times 4 is 4. I'm going to go in, I'm going to add. What's negative 5 plus 4? Negative 1. Okay, and then if I look up at what I had before, the next number that I had to make was negative 1. Again, because this should get us the same answer in the end. What is, for my last one, 1 times negative 1? Negative 1. And then I'm going to go in and add these two together. What is 1 plus negative 1? 0. What do we think this last number represents?
0.
The remainder. Okay. With this remainder, whenever you get to this point, you are not done with division. Do I have an answer yet? No, I have coefficients. So one thing to kind of point out, just so you know terminology-wise, these are going to be the coefficients of the quotient. Now, what that means is these are the numbers that are going to go in front of our x terms. So when you are dividing, just to kind of relate this back to division in general, focusing on the fact that our dividend was x to the fourth and our divisor was an x. If I have x to the fourth over x, what, without thinking of any of the other numbers, what would I end up with?
X cubed.
X cubed. What is 4 minus 1? 3. You're taking 1 away from the top. So we get x cubed. So whenever you look at these problems, you need to look at what is the dividend. You need to look at what is the divisor, because this is going to tell you what the first term is going to be. So when I go in and I start this, my first term is going to have to be what, Wyatt? 4x cubed. Wonderful. So my first term is going to be 4x cubed. Then after that, you drop it down piece by piece. So if my first term is x cubed, what is my second term? X squared. It's always going to go down by 1. And so then I'm going to have, what's my next term? 4x. And then that last one is always going to be a constant. So I'm going to have minus 1. If I had anything for the remainder, I would write it like it was a remainder over the divisor. But since this one had a remainder of 0, we don't have to do anything. What is a divisor? What does it say in the problem? What are you dividing by? What's in the denominator? X minus 1. Over x minus 1. And we'll have one in a second where we'll write it out. So this process simplifies polynomial division, but it only works in certain cases, only when x is x plus or minus a number. So let's try it again without something to compare it to. If you do compare, our answer from number 1 and our answer from number 2 are exactly the same. Same exact answer. One was done with long division, one was done with synthetic division. They both got us the same thing. So let's go in and let's try number 3. First thing I say, go in and make your big L. I start by putting my coefficients inside my box. So that means I need to look at what I have currently, and what you always pay attention to is, are you missing any terms? So whenever you go in, Gabriel, stop. We need to go in and decide if we're missing anything. Remember, you want it to go in descending order. So 4, 3, 2, 1, constant or 0. In this case, I see that I have an x cubed, I have an x squared, but I don't have an x term. So wherever you're missing a term, you're going to put a 0 in its place. So I'm going to start off with 1, 8, 0, negative 16. And that's coming from here, here, my missing term, and negative 16. I will tell you this. Whenever you're doing long division and you forget a 0, it's very noticeable that something is wrong. When you're doing synthetic division and you forget a 0, you can't notice it as easily. And so a lot of the times you just end up with the wrong answer. Be very careful for synthetic division that you're not missing anything. So then I'm going to go out. If I take x minus 2 and I set it equal to 0, what does x equal? 2. So I'm going to put a 2 on the outside. Okay, now for my start process. Remember, the first number is always going to drop, no matter what, because you're never going to change that number. You're basically trying to make that number, which is why it stays the same. And then we go through multiply, add, multiply, add, multiply, add. So I'm going to point it out. I'm going to take 2. I'm going to multiply it times 1. I'm going to write it underneath the next number. That's going to give me a value of what? What's 2 times 1? 2. And then I add these two things together. What's 8 plus 2? 10. And then we repeat. 2 times 10 is what? 20. And then we add, what's 20 plus 0? 20. And then we're going to do the same thing. I'm going to take 2 times 20, and I'm going to put it here. What's 2 times 20? 40. And then here is, what's 40? I know I say plus, but if you have a positive and a negative, you can think of it as minus because one's negative. What's 40 minus 16? 24. So this 24 is going to end up being my remainder. Now, the biggest mistake we see with synthetic division is people forget that they need to think of what is the first term going to be. So always pay attention back to the original problem. The top highest exponent is x cubed. The bottom, the divisor, highest exponent is x. If I take x cubed over x, what do I get? X squared. Now, if you are dividing exponents, you're really subtracting them because 3 minus 1 is 2. So I'm going to end up with x squared. This is going to tell me what my first term has to be. So my first term has to be an x squared. It's always one less than the dividend. So I'm going to take my coefficients and I'm going to write out my answer. So my first coefficient is 1. So you can write 1x squared. I'm just going to write x squared. And then what is my second term? Plus 10x. What is my constant term? Plus 20. Now, for the remainder, you always have to write the remainder over the divisor. So my remainder is 24. My divisor is x minus 2. So here is my answer. Yes?
Get that number divided by from the original equation?
Correct. All right, I want you to try number 4. Oh, wait, never mind. Don't do it. Don't do it. Just kidding. I got to change it.
Why?
Because it's not the same question. Penny, Layton. Shh. Okay, we have a different type of problem. Whenever I go in, we have something called the remainder theorem. So basically, sometimes a problem will ask you to calculate the remainder. And we'll do the synthetic division in just a second to confirm our answer. And what that's telling me is I need to go in and I need to figure out what the remainder is overall. So there's a couple of ways we can do this. The first way we're going to talk about, same thing. We're going to take our divisor and we're going to set divisor equal to 0. So if I take x plus 1, I set it equal to 0, I should be getting x is equal to negative 1. Now what we're going to do, that's step 1. If we want to do like numbered steps, just so you can have an idea. Step 1, set divisor equal to 0, figure out what it is. So step 2 is going to be plug x into the dividend. So basically, I just got x equals negative 1. And so everywhere I see an x in my dividend, I'm going to plug in negative 1. Now we just solve. If I take negative 1 and I raise it to the power of 5, am I going to get positive 1 or am I going to get negative 1? It's an odd exponent, a negative. So this means that I'm going to have 3 times negative 1 plus, I got another odd exponent. What is it going to be, positive or negative? Negative. 5 times negative 1. And then I have minus 2, minus 3. So going in and simplifying this a little bit more. I'm not doing anything other than the algebra of this. 2 times negative 1 and negative 3. So I have negative 3, minus 5, minus 2, minus 3. I have not done anything other than multiplying. That's all I've done. Now, if I have all negatives, am I going to end with a positive number or a negative number? a negative. So there's a couple of ways you can think about this. Personally, I go in and I add them all up, and I just remember that it has to be negative. So what's 3 plus 5? 8. What's 8 plus 2? 10. What's 10 plus 3? 13. So my remainder is negative 13.
Wait, so we got the remainder before the other stuff?
This question, what does the question want? The remainder only. It does not care about the quotient. It just wants the remainder. Now, second kind of idea. Say, for instance, you don't want to do it this way. You want to do it by synthetic division. You can still do it by synthetic division. We can set it up. If I go in and I try out synthetic division, what are my coefficients? I have 3, 0, 5, 0, 2, negative 3.
Wait, I thought we didn't need to do this way.
I said if you want to do it this way, we can try it. So we're trying it out.
Oh, so like stick the last one.
What would my outside number be? Negative 1. We drop. Negative 1 times 3 is negative 3. Negative 3 plus 0, negative 3. What's negative 3 times negative 1? 3. We add, we multiply, we add, we multiply, we add. Hold on, I went too far. I'll go back. You guys were like talking to me like you knew. Okay, where are we at? Here? That's what I had. That's what I had. 5 plus 3 is 8. And then we're going to have negative 8. Right? And then we're going to have negative 8. 8 plus 2, 10, negative 10, negative 13. What remainder did I get from synthetic division? Negative 13. I don't care which way you do it. You can do it either way. You can do it through synthetic division. You can do it through the remainder theorem. You will have questions similar to this on your test. So you have to know one of them, whichever one. Okay, let's try number 5. So for number 5, find a number, b, such that x plus 2 is a factor of this polynomial. And one thing that we're going to highlight here, if it is a factor, that means it should have a remainder of 0. So you may have questions that ask you, is this a factor? But they will not tell you the remainder is 0. You just need to know remainder of 0 is a factor. So I'm going to go in and I'm going to actually set this up again in both ways so you can see how remainder theorem will work and how synthetic division will work. So let's start with remainder theorem. If I take x plus 2 and I set it equal to 0, what do I get? Negative 2. So if I need to make sure that this is a factor, that means I need to end with the remainder theorem being equal to 0. So I'm going to take negative 2, and everywhere inside of my dividend, where there is an x, I'm going to be plugging in negative 2. Now, we said this needs to be a factor, so that means this whole thing has to equal to 0. So I'm going to plug in negative 2. Now, if I have a negative and it's an odd exponent, we already said when we were dealing with negative 1, it's going to stay negative. What is 2 to the power of 3? Negative 8. Okay. So I'm going to have negative 8. What is negative 2 squared? Positive 4. What is positive 4 times 3? 12. B is going to be the variable we're solving for. Okay, so since B is the variable we're solving for, I'm just going to write this as negative 2B. Minus 2 equals 0. All right, Gabe, what's my next step? We will have another seating chart next class period. I will say at this point, blame your classmates.
Can you just put Gabe? Yeah. Can you put Gabe? Just move Gabe to like over there. Yeah, Miss.
Gabe, the whole class wants you to sit by yourself because you can't stop talking. Okay, let's finish this. We got one problem left. Okay, if I combine all of the numbers together, negative 8 plus 12 is what? Positive 4. Positive 4 minus 2 is positive 2. So I have 2 minus 2b is equal to 0. Okay, I'm trying to solve for b. If you are ever trying to solve for a variable, you need to get the variable on one side by itself. So I'm actually going to go in and I'm going to add 2b to both sides. And then I divide both sides by 2.
Couldn't you do the other way? Wait, why can't you just subtract 2 and then add 2 to 0? Oh my gosh.
You can do that as well. It's math.
But I got a different answer.
You should not get a different answer.
I got it right.
We should get the same answer. B is equal to 1. Okay, what's your question? No. We are trying to figure out what number B has to be in order for this to be a factor. So in order for this whole equation to equal to 0, B has to be 1. B has to be 1. Okay, I need you for 2 more minutes, and then we'll work on practice. We're going to try this with synthetic division. Again, I don't care which method you use. So let's set this up with synthetic. We know that in the polynomial, in the dividend, we have the numbers 1, 3, b, negative 2. The outside number is the same thing that we would be plugging in using the remainder theorem. So that's negative 2. So I'm going to put that on the outside.
Can we just put 1 for b? Okay.
It could be 1b. It cannot just be 1. It has to be b, the variable. Now, we said in the end, we wanted the remainder to be what? 0. So I'm going to go ahead and just put 0 here because I know in the end, that's what I need. So by the time we get there, we will have a problem that we are setting up to solve. So everything else is going to stay the same. We're going to drop 1. What is the number I'm going to write underneath 3? Negative 2. 3 plus negative 2 is 1. Same idea. Negative 2 times 1 is negative 2. Here is where you have to be careful. Can I combine b and negative 2 together? No. So I would have to write b minus 2 here because I can't combine those two things together yet. Now, when I go in and I multiply, I'm going to write this side as negative 2 b minus 2 because that's what we're doing. Now, if you wanted to distribute at this point, you can. You can make it negative 2b plus 4. That is completely fine. But what we're really going to be setting up for solving is this last column. Because normally we would add these two things together, we would get our remainder. So normally I would have negative 2 plus negative 2 times b minus 2. Technically we should say minus, but we're going to leave it alone. Don't forget, this is going to distribute. Negative 2 minus 2b plus 4 is equal to 0. And this should start to look somewhat like we did in the remainder theorem. I'm going to have negative 2b plus 2 is equal to 0. What do you prefer, moving the b or moving the 2? The 2, okay. Negative 2b is equal to negative 2. It does not matter which one. Divide by negative 2, divide by negative 2, b is equal to 1. So either method will work. I don't care which one you prefer. Some people like just doing the simple algebra of remainder theorem and not having to set up synthetic division. But both methods, as you can see, are going to get you to the correct answer. So you have to know how to do it in at least one way. All right, you guys have a practice.